Welcome back to Photosynthesis on Catalyst University. My name is Kevin Tokoph. Make sure to like this video and subscribe to the channel for future videos and notifications. Alright, so we've been talking about the two photosystems of the light-dependent reactions, and those in order are photosystem 2 and photosystem 1. And we know that in order for those to function, you have to have, or at least I say you, the plant has to have chlorophyll molecules. And in plants, the main two that we're going to concern ourselves with are chlorophyll A and B. Now, much like when somebody says the term, oh, what hormone is that? Oh, that's estrogen. That can't be right because estrogen is not a molecule. Estrogen is a class of molecules. Okay? Under that class, we have estradiol, estrone, estriol, estrotetraenol. But estrogen itself describes a class, much like chlorophyll describes a class. You have to indicate which chlorophyll you're talking about. There's chlorophyll A, B, there's also some other minor ones, and between different species. If we're talking about bacteria, they have bacteria chlorophyll, and then there's various others, but you have to indicate which one you're talking about. And we're going to talk about in this video something called the chlorophyll cycle. Now, when chlorophyll is first biosynthesized by the plant de novo, the first one that's made is chlorophyll A, and then in general, pretty much all of the others come from chlorophyll A. Now in plants, the main two are chlorophyll A and B. Well, we're going to see, hopefully, how we cycle between the different chlorophylls, and we'll see that it's a pretty simple process, but most of the chlorophylls are going to come from chlorophyll A, and the reason there has to be a chlorophyll cycle to make chlorophyll A and B is to balance the level of the pigments, because chlorophyll A and B, they're going to absorb different wavelengths of light. And so in order to also prevent damage from the sun, but also get all the possible wavelengths that the plant needs, you have to have both of these in order to get all the wavelengths of light. Okay, so it's all about balancing the pigment needs. Okay? And just remember, all the different chlorophylls are going to have slightly different properties. Alright, this right here is what's called the chlorophyll cycle. This is actually the chlorophyll cycle. And generally the way we're going to start this is by talking about chlorophyll A. And this is just going to go in a cycle like this. Okay, there's a few intermediates in there, but we're not really concerned about that. Now, one thing to notice on chlorophyll A, this phytyl chain. Okay, the phytyl chain is this very long chain like this, okay, that exists on chlorophylls A and B. Okay, that's the phytyl chain. The first step in the chlorophyll cycle is chlorophyllase. And what chlorophyllase does is it simply hydrolyzes off that phytyl chain. Okay, every chlorophyllase, and chlorophyllase, by the way, can react with both chlorophyll A and chlorophyll B, but it's going to do the same thing in any case. It's going to hydrolyze off that tail. Okay? Now, whenever we hydrolyze off the phytyl chain, we get the chlorophyllide A. Okay, if we were to hydrolyze off the phytyl chain of chlorophyll B, we'd get chlorophyllide B. So chlorophyll, when you lose the phytyl, it becomes a chlorophyllide. Now, chlorophyllide A can be turned into chlorophyllide B by an enzyme called chlorophyllide A oxygenase. Okay, notice what this is going to do. This methyl group up here at the top, it's going to oxidize that methyl group into an aldehyde as shown right there. That's chlorophyllide A oxygenase. Once we get that aldehyde on there, we can react chlorophyllide B with chlorophyll synthase. What chlorophyll synthase is, it catalyzes essentially the reverse reaction of chlorophyllase up here. It's going to reattach the phytyl chain. So notice here in chlorophyllide B, we just have a simple carboxyl group. When we react with chlorophyll synthase, we get this phytyl chain back. Okay? Then, once we have chlorophyll B, we can either use the chlorophyll B or we can convert it back to chlorophyll A as a balancing act. The chlorophyll B can react with chlorophyll B reductase, enzyme 4 right here, and notice the aldehyde gets reduced to an alcohol. Okay? That gives us this molecule, which is called 7-hydroxychlorophyll A. Okay? If we want to get rid of that hydroxyl group and get back to the methyl group characteristic of chlorophyll A, we need to use enzyme 5 here, which is hydroxychlorophyll A reductase. That's going to completely get rid of this OH and get us back to chlorophyll A. Okay? So this right here is termed the chlorophyll cycle, and it's going to basically interconvert chlorophyll A and chlorophyll B. And this pathway is important from the plant's perspective so that you can balance the levels of chlorophyll A and B and get the appropriate level of pigments. Okay? In other organisms like bacteria that are photosynthetic, there are what we call bacteria chlorophylls. And they're going to have pathways similar to this, although this is the one that's going to occur in plants, the ones we mostly care about. Okay? So hopefully this makes sense and gives you some intuition on how chlorophyll A and chlorophyll B are interconverted. Join us next time, because in the next video we're going to go over a different topic, which is chlorophyll degradation. Thanks for watching the video. Make sure to like and subscribe.